All right, this one's called a mathy example. Really what we're doing between the last formal example and this one is I'm just showing you, as quick as I can, the story of where the formulas that we use for totally elastic collisions in one dimension come from. But in terms of actually problem solving, if you can look up or have written down or just have them in front of you in some way or another, those two formulas and then know how to use them, that's really the main skill that we're looking for in this class, is to be able to do that, because these days it's really easy to look up. Like if you forget a formula, you simply say, well, let's see, am I going to go and derive it, or maybe I can just Google that or something, right? Maybe you just Google it, right, or find it somewhere. Maybe you say, I know which physics book I'm going to open up to find that formula. Anyways, but it's saying the formula that we just got, which was the kind of the difference of the final velocities equal to the difference of the initial velocities. It kind of made sense. I still have this picture here, right? Why was it V1 minus V2? Actually, it's interesting that I did it that way, but it looks like here, right, from this V1 minus V2, I think would be negative, but V2 naught minus V1 zero is also negative. So if I had that reversed, it wouldn't make sense. So maybe I could have gone V2 minus V1 is equal to V1 naught minus V2 naught, but either way, we're just doing math, right? Anyway, but then it says we're going to take that formula and momentum conservation, which is this formula, which we actually use to get to this formula, together with conservation of kinetic energy or mechanical energy, right? But they represent a system of linear equations, right? So if you remember in a math class, maybe at some point you looked at systems of equations where maybe you had like two linear equations with an x and a y, and you had to do like substitutions or add and subtract multiples of the equations to try to eliminate one of the variables and then ultimately solve for both of them. So we're talking about doing that for this, except unlike in a math class, usually there, you just had the two variables and everything else was numbers, which made it a lot easier to do. Here we're looking at these very formal kind of expressions, which makes it a little harder to do. So like I said, I don't really want to slog through all of this math, but if you want to, you can. I'm going to say feel free to do it on your own, because I'm not going to do it. But we're looking for solutions. And maybe the one thing to recognize is, like, what are the two things I'm trying to solve for? Is I'm going to regard these two things, right? V1 final, or really V1 representing the final velocity of object M1, V2 final. Those are the two things I want to solve for. So I want to find formulas that would be like V1 equals something, V2 equals something. But as I said, it's a very mathy example. So I'm just going to say, ta-da! There's the answer. What would you do maybe to find that? For example, you could take this top equation and maybe multiply it by M2 and then add these two together. And what would happen is the V2 parts would cancel out, and then you just solve for V1. So I think that's what you could do to get this first equation. And part of solving for V1 is you'd have to divide, because I think when you multiply by M2 up here and added them, you'd have an M2 V1 plus an M1 V1, and then you combine that and again divide by that total mass, and that kind of explains where those parts come from. And then these parts come from maybe more algebra than I can see all at once right now. And similarly with this one, I don't know, what would you do here? Like, you'd want to eliminate V1, right? So maybe you could multiply the top one by, say, minus M1 and then add them. Or you could say multiply by M1 and then subtract one equation from the other. Doesn't really matter which one you subtract from the other, as long as the V1s cancel. And then you would solve for V2. So if you want to do this by yourself, I've given you verbal instructions for what you can do to do those manipulations. But unless you really love doing algebra for fun, I mean, don't feel like you have to do it for this class. However, these two formulas are very handy. We're going to use them in some examples. So maybe I should write them down here real quick. So we have V1 is equal to, actually, let's see, maybe written here. I don't need this parenthesis. I think I can write it away without it. M1 minus M2. And I'd say if you're getting bored, you can skip to the next video, because I'm just going to be writing these formulas here and probably not saying much else. So if you don't want to watch me write formulas, just go on. They'll already be written. I'm probably going to move them around, though, a little bit. But this is that first formula that I want to have. Oops, it's important I don't forget subscripts for stuff here, right? That one's V2 naught. And then V2 is equal to, that one is 2 M1 over M1 plus M2 V1 naught. It is kind of neat how they're written though, because I don't know, there is like a certain organization here. Hang on, felt like that line was going to be too low. Okay. And it's interesting to notice that each one of these is over the total mass. And again, I think we'll notice as we use these that maybe there's certain things to notice about the sort of structure of these two formulas that'll make sense with the way things actually work in reality, and for the kinds of processes that we might actually want to describe with these two formulas.